All right, here we go for the key for 4.6b, doing some of these proofs. All right, let's find the cursor. All right, so AB is congruent to DE. That is given. And there it is, marked. If it wasn't already marked, I would do it. There it is, bam, bam. And then angle A is congruent to angle D, also part of the given information, and it'll be right there and right there. AC is congruent to DF, there and there, given. And so it looks like a side angle side. The triangles are congruent because of side angle side, two angles, and there. We have two sides, and the angle between them or included between them. And then finally, we can say that once we know the triangles are congruent, right, we basically had a side, an angle, and a side right here. Again, order here doesn't matter. Order in the diagram does, but it is still side, angle, side. Once we know the triangles are congruent, that means now we know that all the other pieces of the other parts of the triangle are congruent. So the corresponding parts of the congruent triangles are going to be congruent. Cpctc. All right. Go to this one over here. Mn is congruent to PQ. We have NO is congruent to QR, and we have OM is congruent to PR. That's given. And then finally, the triangles are congruent. That's an easy one. That's side, side, side. All the sides are congruent there. No reflexive or anything crazy. And so because all the sides are congruent, right, because because three sides are congruent, which is all of them, I guess, that makes the triangles congruent using side, side, side congruence. And now that all the triangles are congruent, or both triangles are congruent, we know that the corresponding parts of the congruent triangles are congruent, which includes angle M and angle P. Those are the corresponding angles. All right, we'll go to this middle one. We know that GH is parallel to IJ, and again, if we didn't know they were wasn't marked, we definitely would, and that is given. And so now I'm looking at the next statement. It's going from parallel lines to angles being congruent. So because lines are parallel, we know that angles will be congruent. So we're going to say, and the angles that we know are IG. Actually, these are the given. Never mind. Take that back for now. But this is the given one. And again, I knew it was the given because it's right there. But it's IGJ and HJG. All right, now the next part, again, we're still going from the part that I didn't use was the fact that the lines were parallel. And because they're parallel, we know that HGJ, which is this angle here, is going to be congruent to this angle here. And that's because if the lines are parallel, right, then alternate interior angles are congruent. We can read that there, comma. Okay, and again, if you see parallel lines, you're thinking alternate interior angles, you're thinking corresponding, mostly alternate interior because we're dealing with interior angle triangles usually in this case. GJ is congruent to GJ, so that's our reflexive side. So it's going to be, the reason why I can say they're congruent, it's part of both, right? It's a reflexive property of congruence. And again, now that I sort of just take a peek at one triangle here, I have, right, so if I have a triangle that looks like this, I have this angle right here, I have this angle here, and I've got that side. So it's going to be angle, side, angle. And again, if we look here, we have an angle, and we have a side. Again, the order here doesn't matter, but you still can at least look at, the amount of angles and sides. Like, two angles, one side. So it's either going to be angle, angle, side, or it's going to be angle, side, angle. So you know it's going to be one of those two. Just like if you looked over here, you had a side and an angle and a side. So you knew it was going to be side, angle, side if you're proving congruence. Because there isn't a side, side, angle. Anyway, so in this case, we look here. It's two angles and their included side. So that is angle, side, angle congruence. The triangles are now congruent. Because the triangles are congruent, we can sort of say any other sides or any other corresponding angles. So in other words, any corresponding parts of those congruent triangles that we just proved congruent are now congruent. Cpctc. All right, I'll do this one just because it's down here. All right, it looks like we have the first part is that, let's see if I can get this. And no, can't. Cool. All right. AB is congruent to DE. That actually is given. So that's AB is congruent to DE. It says that's, wait, let's say, oh, this is the one that was wrong. sorry, it is given, and I'm wrong there. This one I said to change. It says it correctly sort of labeled up top, but it should say parallel right here. Parallel. Okay, and so that is given, all right, as parallel. And again, we're going to look for some congruent angles probably because they're parallel, but we're not there yet. It does say that also that C is the midpoint of AE, and that is a given. And because C is the midpoint of AE, that means C is splitting AE in half, which means that this piece and this piece are congruent. In other words, AC is going to be, yeah, I put that on the wrong line. We actually, we do know that AC is congruent to CE, and actually that is step 4. So I'm just going to write that in. That's actually the definition of midpoint. I just used the midpoint. Them saying it was the midpoint was given, and then we used the fact that it was the midpoint to find that those two segments were congruent. Now we have BAC, which is here. I have to go back a step. And DEC is here, right? Those angles are congruent. And so that actually is, if we sort of look here, we have these two parallel lines. Those two angles are both on this line right here, and they're here and here. Oh, those are alternate interior angles. So again, if the lines are parallel, then we know the alternate interior angles are congruent. Okay, fair enough. Sort of did this one a little out of order, but that's all right. And then finally, we say angle ACB, which is this angle, and angle DCE, which is this angle, are congruent. And of course, we know that's because that's the vertical angle theorem. In other words, vertical angles are congruent, which you can also write in. And then if I just labeling this, it looks like we have an angle, corresponding angle right there, corresponding side right there, the corresponding angle right there. Again, order here doesn't matter, but we still know it's going to be either angle, angle, side, or angle, side, angle. So let's take a look up here. We have these triangles here. We have angles there, side there. Looks like we have two angles and their included sides. So it is angle, side, angle, congruence. And then finally, because the triangles are congruent, we do know that BC would be congruent to CD or DC, that is, because of that they're corresponding parts of those congruent triangles that we proved that were congruent, and they got to be congruent, right? So that's Cpctc. Second page. Cool. We're gonna go. Oh no, missed this one over here. Okay. Okay. So here we go. Go through these a little quicker here. I think I've explained sort of as we go, but if there's anything else, I'll be more than happy to do that. So SU is congruent. That is given. The TU is congruent to TU. That is reflexive. Property of congruence. So the triangles are congruent. Now, in this case, what I would probably say is that this angle, again, I'm going to sort of put this in here sort of as steps. And it would basically be that angle TUV and angle at TUS are right angles, right? And that's because it's sort of given in the diagram. Okay, and then the next thing would be to say that angle TUV, oops, that's a V, is congruent to angle TUS, and that's because the right angle congruence theorem, right angles are congruent. So that's really what we would have in here, even though it's not quite there. So I added it in there. We'll call that sort of like a 2B and 2C reasons, right? Okay, and then finally, with the triangles are congruent, we do know it's side, angle, side. They are right triangles, but doesn't mean it has to be HL. It just means it's a possibility. But we still see, hopefully, that we have two sides and their included angle, right? Those are the two the triangles look like. So that's side, angle, side. All right, and then finally, we know that we end with Cpctc because that is a corresponding part of the triangles that we just proved congruent. All right, so again, you can just fill in pieces of it this time. All right, so we have a given. Cool. The second given is angle G is congruent to angle K. And there, angle G is congruent to angle K. That is given. We do know that GI is congruent to, that is also a given statement. So we got three givens. We know it's side, angle, side congruence. That's how we say it. And so what are the two triangles that are congruent? Well, in this case, it doesn't really matter what I name the first one. I'll just sort of start with this bottom one, HGI. I'll say HGI. I is going to be triangle HGI, that is going to be congruent to triangle, and I have to start with the same corresponding angle, which is going to be L, and then K, and then J. So again, it doesn't matter how I start the first triangle. It doesn't matter that I match it up. And of course, the last step is going to be Cpctc, because again, once we prove the triangle is congruent, the corresponding parts are also going to have to be congruent. All right, in this case, we have angle M and P is congruent to angle OPN, and that's this angle and this angle. We know that MN is congruent to OP, that is given. We know that NP is congruent to NP, that is a reflexive property of congruence. We know that the triangles are congruent because of side, angle, side, and again, it would look like we have two sides right there. They include an angle, so it's side, angle, side congruence. And then finally, it says Cpctc, so I know that I'm looking at one of the remaining corresponding parts, and so what part is it looking for? Oh, we're trying to prove this right here. So that must be it. We're trying to look for these corresponding sides that are congruent in this case. And so there we go. All right. So in this one, okay, so we have the given is that ST is congruent to VU. VU, that is. And again, that's this and this. And then reflexive property would be, of course, TB is congruent to TB. That's property of congruence. Okay. And then we have a step here that I'm going to actually put two steps in here. So I'm going to move it over here as well. Okay. And so I'll just call it 3A. So one of these steps would say that angle S and angle U are right angles. And again, that is because given. It's given in the diagram. And then 3B here would be that angle S is, actually, no. Because I'm not going to ever use these triangles. Sorry, these angles are congruent. What I am going to do is use them to show that the triangles are. So I can actually say triangle TSV and triangle. Let's see, I did TSV, so I'm going to do TUV. Actually, TSV would be VUT. Are right triangles, and again, the reason is that's just the depth of right triangles. Okay, so that should sort of go here. So again, we have to state that especially when I see that we're using HL congruence, we have to say that they're right triangles. So that's this step. Those two steps are in there. Okay. Okay. And then we know that the triangles are congruent, so I'm just going to say triangle TSU is congruent. Again, it doesn't matter, but if I go TSU, that means I need to go with VUT because those angles match up. I basically said TS, which I know is this side, so it has to be VU. So VUT, triangle VUT. And then finally, we know it's Cpctc because, again, once we prove the triangle is congruent, we know the corresponding parts of congruent triangles are congruent. All right, in this case, I should have a pretty good idea that we're going to be doing that reflexive, but our first given, it doesn't actually matter, I guess, which one we're doing first, but we could say AC is going to be congruent to, I can't see my pen, okay, to CE. Again, that is given. Come on. Then we say that, let's get this in there. Then we say that DC is congruent to BC. Again, that's given. They're marked up there already. We have angle ACB and angle DCE are congruent. And of course, that's because vertical angles are congruent. Vertical angle theorem. The triangles are congruent in this case because of side, angle, side. So again, angle B and angle D are part of those congruent triangles, and they're corresponding parts of those congruent triangles. So they have to be congruent. All right. All right, in this case, we have SU, here they are here. We have a reflexive situation going on right here, so that would have to be TU is congruent to TU, reflexive property of congruence. This, of course, was given. Okay, and then with the fact that it's HL congruence means we would have to say that it's a right triangle. So again, we'd have to say, the angle STU and angle VUT are right angles, and that's given in the diagram. And then we would also say that that because we're using HL, that triangle STU and triangle VUT are right triangles. And then again, that would just be because of the definition of a right triangle. And again, these steps would fit somewhere in here. Okay. And so now we can say that the triangles are congruent. So triangle STU are going to be congruent to triangle VUT. Sorry that my V's and U's look the same. And then finally, we can say, what are we trying to actually prove? We need to know, we know it's Cpctc, but which part, well, we're trying to prove this, so we can just jump straight there. Those are corresponding parts of these congruent triangles. Therefore, they're congruent. All right, look here, we got some parallel lines. This is our given. AB is parallel to DE. That is given, and they're marked already. The other given is that AE bisects BD. Okay, and so we know that AE is, so well, let's look at these angles first, because it says ABC, which is here, and angle EDC, which is here, are congruent. And then we know that ACB, okay, well, let's do this one first, because this is the fact that because they're parallel, and I should have written this down in here, in other words, that they're parallel up here, as given, and then I should, didn't I write this in? What happened to it? I don't even know. Okay. Anyway, ABC. So we know that if because these lines are parallel, then these are alternate interior angles. So again, if the lines are parallel, then alternate interior angles are congruent. And then it says ACB, which is this angle, and DCE, which is this angle. So make sure we're marking it. DCE, there it is. And then, of course, that's vertical angle theorem. And then this is definite. Oh, good. I did write it in. I wasn't going crazy. Okay, so hopefully we can read that, even though it's doubled up. It looks a little weird, but it's okay. I don't know. No, whatever. I'm going to leave it in there. Easier that way. Okay. Anyway, I was right over it, but okay. Anyway, definition of bisect, because what we're ending up here is we're saying AE is splitting BD in half. So BD is being cut into two equal parts. And so what we need to know is that, and this should be definition of segment bisector. So I'm just going to write seg in the there. And it's going to be BC is going to be congruent to CD. In other words, AE is not being bisected, it's bisecting. It's cutting BD in half. So BD gets split into two parts, BC and CD, right? So it's being split into those equal congruent parts. Okay, so that's what's happening there. And so the triangles are congruent in this case using angle, side, angle. We have two angles. Right, we basically have, two angles and their included side. All right. And then because we're trying to prove AC is congruent to EC, and those are corresponding parts of these two triangles, and I just proved them congruent, that means I know that they're also congruent, so Cpctc. Okay. Looks like in this case we have, let me tilt the mic here. So we're dealing with these lines are parallel. It is already marked. We have these two, which are angles are congruent, which is given. That's already marked. The next thing is, we have another given, and that's GH is congruent to IJ. So GH is congruent to IJ. They're parallel, given. Okay. All right, and so the fact that these two angles right here are actually going to be congruent. And again, why are they congruent? So these are the angles I'm looking at. So these ones we would have to figure out. It would be HGI is congruent to angle JIK. And again, if I look at the parallel lines like this with where these angles are, it's actually here and here. In other words, those aren't alternate interior. And I think I mentioned this in class, that those aren't alternate interior angles, those are corresponding angles. So in other words, if corresponding angles are congruent, actually the other way around, it should be then, so if the lines are parallel, then corresponding angles are congruent. A lot of room in there. All right. Okay, now that I have enough information, I can say these triangles are congruent. And again, we can sort of take a look and say we have an angle there, side between it. So we know it's going to be angle, side, angle congruence. And so we can say that triangle HGI is congruent to triangle JIK. And again, we're trying to prove those angles are congruent. Those are corresponding parts of these triangles that I just proved congruent. So we can say that Cpctc. In other words, angle GIH is going to be congruent to angle IKJ because of Cpctc. All right. We have two sets of parallel lines in this case. So one of them's marked right here. That is given. We know the other one has to be MN is going to be parallel to PO. And then we have angle. So then based on the fact that these are parallel, right, we can say PMO. We can say because, again, these lines are parallel, then we know that these angles are going to be congruent, which is going to be PMO and NOP. And that's just going to be because if parallel, then alternate interior angles are congruent. And then we have alternate interior again, which is the same reason. So I'm not even going to rewrite it. I'm just going to say it's the same reason. But what angles are going to be congruent? Well, again, if we use these being parallel, right, then I could look at the same. I could look at these being parallel on the same line. So it's going to be this angle and this angle, which would be here and here. So that's going to be angle NMO is going to be congruent NMO and POM angle. And again, that's the same reason. And then we do know the reflexive side there. So it's MO is congruent to MO. So we have reflexive property of equality. So congruence. Okay. And then we have, it says it's ASA. We knew that because we could see two angles in their included side. So we're going to name these triangles. We're going to say triangle. Again, it doesn't matter how you name the first one. We just have to make sure we're matching up the vertices in this second one. And I did the same triangle, which is not two congruent triangles. So, and eraser is definitely working. Okay. Okay, so we can say POM for triangle POM. Okay, and then finally we're trying to prove that segment PM is going to be congruent to segment ON. I hope these are just being left off because all these should have line segments above them, or otherwise they wouldn't be congruent. They should say equal. Then we have to be dealing with a whole other step. But either way, with Cpctc, I assume those are okay. All right, finally we can get to these last two here. It does say we can just write in the two givens, which we know is we have that ST is parallel to WV, and we know that I can't see it, ST is congruent to VW. Okay, those are both given, and they're both marked. And we know, again, if parallel alternate interior angles are congruent, so let's fill that in. And again, which angles would that be? We actually have our pick. So it does say also SUT, and actually this is where we have to look ahead a little bit because it says angle SUT and angle VU or WUV, which we know are vertical angles. So that's vertical angle theorem. And so what I'm looking for is angle side. Actually, so it wouldn't really matter either way, actually, whichever way we do it. So I'm just going to say angle S is congruent to angle W. In other words, these two right here, because they're alternate interior angles, Second one there. Of course, we could have said angle T and angle V also would have been fine, but either way, it would have been angle, side, so it wouldn't actually have mattered for that context as well, or in that regard. That's fine. But we know that triangle STU is now congruent to triangle STU, so we're going to say WVU. Okay. And then finally, we know that SU has to be congruent. I think that angle symbol is not supposed to be there, to WU. And again, that is because of Cpctc. All right, last one here. We've got 3 givens, actually. So the first one's there. Second one's there. The last one needs to be right here. And again, if I look on the diagram, they actually all are marked, and that's great. And of course, we know that these triangles are going to be congruent using side, side, side. They're all 3 sides. What are the triangles? Let's name them. Triangle ABC is congruent to triangle CDE. And again, we can say that angle A is congruent to angle DCE because those are corresponding parts of congruent triangles. Therefore, they're congruent. All right, people. Sounds good.